This video looks at the statistician William Playfair. He was the inventor of the line graph, the bar chart and the pie chart. What makes him relevant in middle years maths education is that the graphic methods he developed are applied by students today in a manner unchanged from Playfair's original applications. He's also interesting and important because of his circumstances and because of his application of graphic representation to mathematical knowledge. He had the vision to develop a new graphic language, and his circumstances meant that he was born into the right family, at the right place and at the right time. From the age of 12, William Playfair was raised by his older brother, John Playfair. Now, John was an accomplished scientist and mathematician, so he was surrounded by maths and science from an early age. John, his brother, was also a professor of natural philosophy at the University of Edinburgh, so he's highly regarded. Now, William's early training when he left school was with Andrew Meikle, who was the inventor of the threshing machine, and with James Watt. Now, James Watt, as you know, developed the locomotive. It's a bit like saying today that your early training's with Bill Gates and with Steve Jobs. Next, his graphic training came from working with cartographers. Now, Playfair lived in the golden age of map making, and he worked with world-class cartographers, both in France and in England, and he adapted their skills and their conventions to his graphic needs. Most importantly, though, from a late 20th century perspective, William Playfair understood what we would call the ability of statistical graphs to exploit our natural perceptual and cognitive capacities. In other words, our brain understands visually what his graphs are telling us. And complex information could be presented in a way that our brain can easily comprehend. Playfair was motivated by a desire to establish a reputation amongst the elites, or as he refers to them, statesmen and those in power. He wanted to create a market in these elites for his publications and then reap the rewards. Meanwhile, he supported himself doing engineering with the likes of Watt, etc., and that's the way he supported his family, while all the time he was pursuing his publishing ambitions. Playfair's purpose was to use his skills and knowledge to publish and market economic information and to profit greatly from it. So he set out to develop tools that would engage his audience, and his audience was the rich and the powerful. So how did he go about it? Well, it's the how that makes him so important today. Playfair was the first to devise and publish the time series line graph, the bar chart, the pie chart, and the circle chart. Modern statistical graphs are almost identical to those published by Playfair, and each of these statistical graph types are used and understood today. Middle years maths students learn how to use statistics to construct, to display and to interpret graphic representations. They do this on the line graph, they do this using bar charts, and they do this using pie graphs as well. They measure changes over time, they measure parts against the whole, and they use statistics to demonstrate meaning. The original chart you see here was developed by Playfair and used in his publication called The Commercial and Political Atlas of 1786. The annotations to the side or on the graph have been added by Ian Spence from the University of Toronto. On a side note, Spence is a psychologist. He's known for his work on graphical perception and on the history of statistical graphics and on the life and work of Playfair. So he's the right person to show the psychology behind what Playfair is doing. Back to the graph. The graphic elements that Playfair combines here are designed to work very comfortably with our cognitive capacity, and today we understand them at a glance. Playfair identified and used ideas that were already available to him. For example, the horizontal and vertical axes. He then developed codes and conventions such as using a grid, labelling lines and using captions rather than using a remote legend distant from the time series, so you had to look away from the graph to find out what it meant. He used colour identifiers, but importantly he used no more than 3 or 4 in the one chart. And he labelled the axes. directly. Again, rather than using a remote legend where you have to look away to find out what the axes are measuring. We take these conventions for granted today. They are so intuitive and straightforward that primary students are taught how to apply them. Our cognitive capacity hasn't changed, so Playfair's graphic language hasn't needed to change either. He got it right the first time. One design that Playfair pioneered and then promptly denounced was the bar chart. It appeared only once in the Commercial and Political Atlas. Playfair bemoaned its lack of insight over time, calling the graph much inferior in utility. For his audience, the bar chart was of limited use, but for students in the middle years, the chart is a really effective starting point. This chart measures the volume of imports to Scotland against countries of export. Because it's limited to 2 variables, it gives a limited snapshot of the statistics that it uses. Middle year students will often use the bar chart to measure class data. For example, likes and dislikes, number of siblings, distance from school, etc. The next step in use might be measuring school student numbers over a period of time rather than as a volume. Because of its relative simplicity, the bar chart is a common starting point for middle year students learning how to graph data. It needs to be kept in mind that it's an effective starting point in a process of deeper awareness and deeper application of graphic representation. In his volume, The Statistical Breviary, Playfair introduced 3 new forms of statistical graph: the circle diagram, the pie chart, and the Venn-like diagram, which was used to show joint properties. As in the case of the line and the bar charts that he had introduced 15 years previously, the basic designs here are sound and have scarcely been improved upon to this day. This multivariate display is special for 2 reasons. Firstly, because of its ingenious combination of data elements that provides at one view the physical size of each country, the size of its population, its tax burden, and how they interact. And secondly, the breviary introduced the pie chart and this Venn-like diagram. In his own life, he died in relative poverty. He was not accepted in Great Britain because he'd put too many important people offside. In Britain, it was the era of the Industrial Revolution and the invention of great machines. It was not the era of the author, and Playfair's obituary makes this point. Had Mr. Playfair cultivated his mechanical genius, there is no doubt that he would not only have obtained considerable eminence, but have rendered no inconsiderable service to this country. Unhappily, however, for his own interests, he had the ambition to become an author. The legacy of his graphic language was fully realised in the 20th century. Graphing statistics and using graphs has been part of middle years curriculum throughout the past 50 years. And in the commercial world, Playfair's graphic creations accounted for about 50% of all diagrams used in news magazines and between 60 and 80% in the business and scientific press. That was measured in the late 1990s. Maybe this would not have been the case had he cultivated his mechanical genius.